Thank you so much, Depesh, and welcome everybody. Very excited to have you here today and for me to moderate this esteemed panel. And we're going to be talking about AI, ML, and edge computing. And there's a lot between those bookends, so be prepared. I will be your humble moderator today. I am Group Vice President on the New Ventures and Innovation team at NTT. I'm based in Austin, but my role is global. And I have with me today four panelists. And what we will do is I will first share with you and introduce our panelists. And then I wanted to show a quick video. Our conversation today is going to have multiple facets across academia, infrastructure, business, strategy. We're going to cover a lot of ground. But the video that I'll share with you, once I share who our panelists are today, is from Audience. And we have somebody from Audience with us today, part of that team. And Audience is a 360-degree XR 8K plus remote participation standards-based live platform with multiple use cases. Audience was one of the first platforms deployed on the edge on hyperscalers in Canada, the USA, and Europe with tier 1 operators. So before we cut to that video, I just wanted to share that who will be joining us in this conversation today to cover all of those facets in this summit, where we're exploring the role and the relevance that these emerging technologies have in the digital transformation agenda, and fundamentally, how industries around the world are going to not just survive coming out of the pandemic, but to thrive on the other side of it. And so today I will be joined by Tomasso Melodia. Tomasso is director of the Institute of Wireless Internet of Things at Northeastern University. We have Ravi Guntupalli, he's Director of Technology at Cisco. And we have Jeff Nezon, who is a Senior Sales Executive at Summit Tech. And we have Daniel Jacobison, who is a Research Assistant Professor at Virginia Tech. But before we hear from these wise, experienced leaders across industry, let's take a quick look at that video.
And just like that, presenting Summit's 5G MEC Audience 360 platform. We've recently launched in the US on live carrier 5G networks, including spot trials at our studio in Montreal, where we've demonstrated virtual live stream shopping, live performances, and esports. Ultra low latency live 8K video with embedded carrier communication and interactive in-stream apps. Audience elevates live events beyond the metaverse with immersive 360-degree experiences in the real world now.
Thank you, Audience, for sharing that with us. Live audiences beyond the metaverse. I'm still trying to wrap my mind around what that looks like, and hopefully we'll get to that today. Okay, so let me ask each of our panelists to please introduce themselves. I've already shared your affiliation, but I would really love for you to share a little bit about your background, specifically how you fell in love with this space in the emerging technology landscape, and also what your organization, whether it's the academic part or the commercial part, strategic, what your objectives are. So, Tomasso, can we start with you, please?
Sure, absolutely. Tomasso Melodia from Northeastern University. I'm a professor of electrical and computer engineering, and founded and direct the Institute for the Wireless Internet of Things, which is a research institute, a think tank, and a technology incubator that coalesces the strengths of the university in future wireless systems, its societal implications, and applications of AI in smart wireless systems. And we have about 120 people today between faculty, researchers, and PhD students working in this area. I am also the Director of Research for the NSF Power Project Office. Power, or Platforms for Advanced Wireless Research, is a public-private partnership that is building 4 city-scale platforms or testbeds for advanced wireless research, programmable and with edge AI capabilities. My personal research is in modeling, optimization, experimental evaluation of wireless systems, been focusing on developing architectures, algorithms, and testbeds for control of open run systems based on artificial intelligence, and on spectrum sharing and slicing for 5G based on AI. I'm also part of the AI Edge Institute, that is one of the new National Science Foundation AI Institute, led by Ohio State, that is looking to bring fundamental advances in AI for network control at the edge. So that's about it.
Thank you, Tomasso. And I know there was a scare recently at Northeastern with a package, potentially explosive package and whatnot. And there's all kinds of speculation that's going on as to what the intent of that was. So first of all, please, extending our wishes for safe premises and experiences of the student and faculty at Northeastern. Just wanted to underscore that. And also, to thank you for the research that you do, because I think what we're focused on is where a lot of these advances in technology are really going to make an impact in a way that unifies and doesn't create, some of the more challenging situations perhaps where technology could go. So just wanted to punctuate that. So
thank you. It's helpful.
Yeah. Ravi, please introduce yourself.
Hi, all. This is Ravi Guntupalli. I'm with Cisco as the Director of Technology. I primarily focus on mobility innovations within our CTO organization. And thanks, Rika, for the great introduction today. And from our perspective, we've been focused on what we can do from next generation towards our service provider and enterprise channels to make sure that they can actually leverage edge use cases more realistically, rather than just theoretical aspect, but primarily making sure that edge can be leveraged within their architecture, bringing in some intelligence into how they consume things on a day-to-day basis, so that our service provider partners can also monetize it. But at the end goal for us is to make sure that the enterprises and the consumers have a better experience with the edge, right? So that's what we've been focused on.
Great. Thank you, Ravi. And Jeff?
Well, first of all, Rika, thank you for having us. And Mitra, thank you for having us, and what a distinguished group, so I appreciate that. So I'm a 30-year veteran, 30-year plus, like a lot of the folks here, a 30-year plus veteran in telecom. Started on the first digital switches in NT, Northern Telecom, and then moved into content management systems, into IMS, into APIs, and then started running innovations labs out of Chicago. At about that, 2014, my team ended up doing some work with Summitech. We built one of the first connected cars for the GSMA Innovation City. And that connected car was a Fiat 500. My team, as part of some of the applications, also virtualized one of the first IMSs, and we put it in the trunk of the car. So that was the first mobile cloud, I think, with what we ended up doing. Fast forward a number of years, and I saw the MVP on Audience, and I said I had to be part of it. So we'll talk a little bit about what Audience is, but really, as you move forward in your career, you start to see things commercialize, and things that you worked on earlier commercialize, and that's a very exciting field for me. The business around the technology that you helped develop.
Yeah. So Jeff, I'm looking at you, and you say you're in the industry 30 years. Did you start when you were like 5? Were you like coding?
No, I just got a haircut. That's
No, that's incredible. Certainly, you must have experienced all kinds of interesting convergences, which we'll talk about too today. Welcome. And then last but certainly not least, Daniel, please.
Yes. Hey, everyone. I'm Daniel Jacobison. I'm a research assistant professor at Virginia Tech. I work for a group at Virginia Tech that is called the National Security Institute, VTNSI, also Hume Center, if you all are familiar with that group. But I've been in this position for about 2 years. Before that, I was working in kind of the patent world, a lot of deep dives into 4G and 5G protocols as part of that work. And prior to that work, I was actually at Virginia Tech doing my graduate work, and that was kind of my introduction into the world of wireless and telecom was through graduate school, and really developed a love for this field. And so excited to now be back into the kind of the academic world again. My research is focused on resiliency in communication systems, and as things have progressed, and there is interest in both commercial and defense uses of 5G systems, we're really interested in how do we further secure 5G systems. I would say that my work and the work of a lot of my colleagues at the Virginia Tech National Security Institute also is about spectral awareness and how do we use AI and ML to really understand what's going on in the spectral environment, which I think is really important as we have further and further instances of new spectrum that's being opened up that has requirements for sharing with federal systems and the like. So that's one of the other areas of our work. So excited to be with you all.
Wonderful. Thank you, Daniel. Sorry for mispronouncing your last name. I'm half German, and sometimes the Germanic pronunciation dominates. Apologies for that.
Yeah, no worries.
So I'll give a little bit of my background. Perhaps I think this is why the Extraordinary Meter team asked me to moderate this panel. I've been a woman in technology my whole career. I fell in love with wireless when I was back in Japan, which is where I'm born and raised. I was in Japan when Docomo, NTT Docomo launched iMode. So it's fortuitous that I'm now full circle back at NTT. But iMode really captured my imagination around what was possible around content distribution and experiences of users, whether that was business or consumer. And from there, I went to work for Accenture, where I worked on a lot of special projects, a lot of it around emerging technology. So when DRM and DCM, digital rights management, digital content management was still this new thing. And from there, I went to Nvidia. And I was actually part of the team that was working on the discrete GPU architecture when we were trying to do discrete GPUs on phones and drive H.264. I'm completely aging myself now. And we were talking about design wins around 2 megapixel cameras on flip phones. So now I'm really aging myself. But so I've been in these various forms of where these technologies converge and really spark innovation within the world of academia. Certainly, a lot of the investments that we make at NTT is in R&D and working with a lot of universities in collaboration. And I think this whole arena of private-public partnerships and university partnerships, I think that's, frankly, why Silicon Valley has really emerged as one of the places to go around innovation, is because of that collaborative environment that creates. And so coming into this panel, which is where we're going to talk about technologies that on the surface and by the nomenclature is not necessarily new. I mean, we all know how from Space Odyssey, an AI bot. We all remember when ATMs showed up on our corner streets that were an example of edge computing. So this whole topic around AI, ML, and edge computing sitting under the conference category of advanced technology and changing dynamics of telecom is a really interesting juxtaposition, I think, of how the digitalization of COVID-19, which really forced this digitalization and digitization, and those are two very different things, not very different, closely related, but different things in my mind. And the ways that we need to harness and really take on some of the interesting challenges that have been emerging out of that, either from a research problem statement or something around strategic go-to-market and things like that. So that's what I'm really looking forward to talking to all of you about. And I'm not the kind of moderator that necessarily calls on the panelists. I really would love for you to jump in and have it as a conversation. And I get the sense that all of you love the healthy debate, so I welcome that as well. Of course, I have some guiding questions here to move us along, and hopefully we'll be able to engage the audience to reach out to each and every one of you as we go through this. So without much further ado, I'm going to do a little bit of soft pitch, just to get us all warmed up around the field. So what have been your observations about how AI ML has advanced, perhaps since the time of Space Odyssey, perhaps Jeff from the time that you were 5 working on boards and code, but especially with how digitalization has really drenched the economic, academic, and political landscape for that matter. So whoever would like to go first, please jump in.
I guess I can kick it off, Rika,
Okay,
right? So
yes.
this is Ravi. So yeah, just in general, when we the whole COVID-19 kicked in, right? So one of the interesting angles that we did not see coming until maybe 6 months into this whole thing is how people are going to use the technologies that we've always had at our disposal, but how you're going to leverage that, right? The growth of the whole hybrid work changed, and as the mechanism on how people started experiencing this virtual environment where some people are physically in the office, some are not, or even like my kids were taking all their classrooms online, we quickly realized there is an ability of learning that was required on this digitization platform, right? For example, even today, right, as I sit on this panel, like I'm having technical issues on exactly how my video is working and whatnot. I wish there was a little bit of intelligence built into the system that would basically adapt it and say, you know what, I should have anchored Ravi in a different location, for example, right? So that his video stream is better, right? So we started learning a little bit of that. And then based on those learnings, we started enhancing a lot of those technologies. In my opinion, if COVID did not come in, unfortunate, but at the same time, if COVID did not come in, some of these technologies would have been dormant for another 6 years. I think it just accelerated some of that stuff for us. We started building those machine learning capabilities into everything that we do so we can understand how the user experiences on a real time and change the way the application adapts or change the way where we anchor the user. So essentially, we started pushing out edge. So in theory, for this panel, to a certain extent, I think COVID accelerated a little bit of the edge deployment so that we can change the experience of the end users, whether it's physical devices that are have a head that like an iPhone and whatnot, but or even IoT devices like connected cars. It changed the landscape quite a bit for us to actually move things more closer to the edge.
Mm-hmm. Yeah, no, that's and I think the expectations have shifted dramatically from what experiences users are demanding. And actually, Jeff, if you don't mind, I'm going to go to you for a moment because since Ravi touched on experiences and since the audience reel was really emphatic about the remarkable experiences beyond metaverse and beyond that we're going to take us. What have you observed, right? That you would say is like before COVID or post COVID, and if you don't want to have that demarcation, that's fine too. But we'd love to hear like where you see how things have gone in terms of what's really real and what's actualized now.
Look, from our perspective, this was on our roadmap before COVID, and the edge was really the eureka moment for us, the mech, being able to transport that high quality video and aggregate it at the edge. What it did is it started to define some of the use cases on the platform, right? So, people are locked at home. Is shopping the use case? Is concerts the use case? But it's really been part of the platform since before COVID. The edge and really the operators and the hyperscalers opening up the edge to ISVs is really the moment where we can start to commercialize things, where we can bring our CDN costs down by 200%. And it's not necessarily COVID. I think that's an opportunity, and it certainly built awareness, and it certainly was the appropriate use cases to run all of our trials on and all the measurements on. But it's always been part of our product, and it's always been part of the direction and the strategy of the product. And as we talked about earlier in some earlier discussions, standards and what Sebastian was talking about, because we are standards based, so we could roll that in to the service providers, to the operators. It took us about a week to move to the edge.
Yeah. And so you point out something that I think is really pertinent, and I'm going to come to Daniel and Tomasso here in a moment. So there's been a lot of money that's gone into this space, that's been accelerated by the hyperscalers and the usual suspects, Zoom, Google, all these companies that were investment going in, and then them expending the money in the space. So how has that funding that's gone into the space, has it or has it not impacted research? And also, in what ways has it impacted research? So Tomasso, Daniel, for you in the academia world, and in what ways has it really impacted the areas of focus It's kind of a different flavor of the question that I'm asking the panel, but if you don't mind addressing that.
Sure. Maybe I can take a stab at that and then leave it to Daniel. So I think there is during the past 2.5 years, certainly in the area where I do research, right, the area of network control and inference in wireless networks with AI, there's been significant progress. And I don't know if that was because people were at home and had more time to work, or because we had increased funding. I think it's a little bit of both. I would say 2-3 years ago, not a lot of people were taking AI at the edge and AI for network control very seriously, and there's been now everybody's into that, and that's looking at developing products and at developing capabilities. AI and machine learning and Open RAN are intimately connected, and with your architecture now, for the first time, we can control the network through abstractions that expose the control functionalities, and we can develop all these new models that can provide fine-grained end-to-end control from the core to orchestration of the network functionalities to the edge and to the radio access network, and even very close to the radio access network. So I think that there's been a lot of exciting progress in this area, and what we need is more of what has happened in the past few years. That is coalitions of academic researchers, industry, and even local communities that can, push technologies forward, bring real innovation, and sort of overcome the valley of death for technologies.
Mm-hmm. Daniel, what about you?
Yeah, I'd say that from my perspective, I think one thing that has really driven AI and ML forward in a variety of applications, including the wireless space, is seeing how well the applications to image, speech, and video processing have advanced in AI and ML. So I think that's been, image processing is a visual thing. You can see the effects of machine learning and AI applied there, and I think it's been a kind of a leading application that has then brought people's awareness up on that. Okay, AI and ML are very good. We need to explore this. I think we've seen that from our customers, those who are coming to us for research at Virginia Tech, that there is a growing theme of, even if we're not working with them on an AI ML project, there's always the question of, hey, should we be thinking about AI and ML in this application? So I think that discussion has really become a theme throughout kind of all the research that we do. And then Tomasso mentioned Open RAN, but I think Open RAN is very significant because it provides that platform for us to take what we might be developing conceptually or in the algorithmic world and drop it into a network and see how it performs. So,
absolutely.
Yeah. So, Tomasso, I think you touched on something around an infrastructure for test beds, right? So, with NTT, we have these innovation labs, right? These sandboxes that enable that kind of coalition to congregate and to actualize things that have meaningful impact mechanistically, clinically, or in the real world. And I'd love to hear if you have any examples of good, so if anybody that's in the audience, for example, if they wanted to understand a little bit more how they could tap into some of the research that happens in the academia world without feeling like it's going to get pulled into just the groove of that record, but really has the opportunity to do a private academic partnership. But like, what does that infrastructure look like? How would people be able to engage and be part of that innovation?
Yeah, absolutely. Thanks for the question. So I mentioned at the beginning, my brief introduction, I've been involved with the Platforms for Advanced Wireless Research program that's been spearheaded by the National Science Foundation, known as POWER, right? POWER, in a nutshell, is trying to build a fabric of test beds, programmable test beds, for advanced wireless research in the North American territory. And it's trying to do, I think, a couple of things for the first time in this area. First, it's been funded by a coalition of industry and government, right? It's a public-private partnership. The National Science Foundation has invested $50 million into this program, and there is a consortium of industry players that have matched the NSF contribution with in-kind and other contribution. And then it's been trying to create coalitions to perform research on these test beds, coalitions of academic researchers, of industry, and local communities that may have specific applications and use cases for these test beds. All of the test beds, there is a wide variety of test beds in the territory. There is one in Salt Lake City, Powder, Cosmos in New York City, AirPow in North Carolina, and ERA in Iowa. They all have a similar philosophy of bringing together softwareized wireless networks with edge computational capabilities, the ability to do AI at the edge, as well as the ability to create end-to-end network connectivity with interconnection with fixed network. And I think that there's already an incredible amount of resources. In addition to that, there's also the Colosseum emulator that we have at Northeastern that is part of the Power family of platforms that can provide really a lot of open run, spectrum sharing, edge capabilities, and ability to test a number of different use cases. All of this suite of Power platforms, I think, can really help provide a glance into the future and have capabilities that can benefit the community and create innovation.
Can you hear me okay?
Yep.
Oh, okay. Sorry, I went offline for a moment. I need private 5G in my hotel room. I'm in the Bay Area, full disclosure, so there's no doubt all kinds of competition going on for bandwidth being here. Thank you very much, Tomasso. So what I wanted to do actually, so Ravi, NTT and Cisco are fast and furious partners. We do a lot of work together. We've brought a lot of great magic into the world around connectivity. Going back to the term that Tomasso mentioned, he says softwareized, which I haven't used yet, so I'm going to use that because we keep using software enabled, but I like softwareized. So Cisco's really demonstrated the ability to adapt to a softwareized, increasingly softwareized world. And what I'd love to hear your perspective on is, given that this panel brings together like a layer cake, AI, ML, and edge computing, can you share with us, do you think that those two are now becoming inextricable? And to the extent that you can share, any kinds of partnerships or roadmap views that you have about how that inextricability is going to play out in the coming months and years ahead.
Right. Yeah, the way I've always seen it, Rika, is that when you look at AI, ML, edge computing, and some of the capabilities that we've been looking at, it really comes down to a vertical or a specific use case kind of a deployment. Ideally, I would love to put our software with intelligence everywhere in the world. And we are actually understanding, because we get visibility into what's happening across the networks, right? Given Cisco's presence both on the networking layer as well as within the enterprise layer, we get visibility into what's happening across the layer. The challenge is sometimes you don't want to throw in AI ML for the sake of throwing it in, right? So I see this more of, if I look at a use case and I see a pattern of behavior that is happening, an experience that is being impacted, you learn from the behavior and then start bringing in the software capabilities to enhance that, right? So ideally, let's say a connected car use case that we were just talking about, right? So in a connected car use case, let's say the users in the connected car are no longer now just looking at telematics, but more looking at Wi-Fi hotspots in the cars. They're looking at potentially being able to stream video onto the big panels that are in the cars these days, right? So the experience changes quite a bit. Can I throw AI ML into that mix and say, if the car is actually driving from region A to region B, my streaming server is going to change? Yes, that is a perfect use case, right? So we've been bringing that capabilities into the mix, right? But when I take this and apply to a simple scenario like an IoT use case, a camera that is broadcasting, there might not be a lot of AI ML scenario unless I'm able to do facial recognition or some of those capabilities at the edge as well. right? So I'm bringing those capabilities around, like, camera devices, and this is where hybrid work environments have changed a little bit of things for us. So now we are bringing in capabilities around when the users start walking into the office space. How do I use AI ML within the hybrid work environment and identify how many users are sitting in the conference room? And if it's more than 7, flag it, right? So I'm able to do all of that stuff, right? So a lot of this partnership depend upon the vertical use cases rather than just saying I have to throw in AI ML at every single one of the edge deployment use cases. So I don't know if that's what you're looking for.
Yeah, no, that makes a lot of sense. And I know, Jeff, this is an area too, right, that I think is rife for debate, because I think in perhaps in the world that you inhabit, is the question is, well, what role does AI or ML play? Because if for example, as Tomasso or Daniel were talking about earlier, as machine vision, well, machine vision has a whole host of different applications.
Sure.
Machine vision, but I'd love to hear your thoughts on that Siamese twinship of AI, ML.
For us, it's part of it's inherent to the platform, right? Part of the platform, so we're layering in a whole bunch of sociality into the platform. We have chat as part of that. So if we're doing mass chat, we need to have the AI associated with profanity. We need to have the AI associated with measuring natural language, because there's moderation in there. And if somebody getting angry, we are bridging physical and virtual space. We're taking the audience platform that's on your phone, but we're also bringing it to a video wall. So whether it's at the concert or whether it's in a venue or in a store, well, we've got video detection to detect nudity, those kind of things as part of moderation that has to happen when something's live and thousands of people are there. And then we've also got object detection, because we want somebody to buy something, so we want them to touch it, and up comes the chatbot and the commerce associated with it. So and it has to do that at the speed of 5G and the edge, to make sure that it is real time. We can't have somebody clap or do something and not have that in sync with the rest of the video.
Yeah, and we're talking quite a bit about with the edge computing happening at the edge. What I do want to do is tie it back, because one of the things that we're looking at is this convergence of a lot of different facets of traditional into the modern era. Do any of you want to address the question of what are some of the challenges of trying to converge wireless networks with AI and ML, with a lot of that power happening at the edge, but some of the utility of it having to rely on networks?
I can jump in, right? So just
go ahead.
Sorry,
and then I'll give my perspective after.
Yeah, so one of the things that we run a small team with that actually contributes into the 3GPP specifications as well. Right? When you look at the network aspects of things, Rika, right? The specifications have defined a lot of these capabilities of saying my edge application server is able to influence exactly what happens for my application. I want to be able to tell the network that I want this particular device to be anchored on this particular user plane function, and so I can steer the traffic. But it is not always that trivial, right? Because now the moment I anchor that particular device at the edge location within the network, I need to make sure I have the corresponding application that is the user is consuming is available at that particular edge location, or I have optimal routing aspects on that. So trying to understand everything that happens in a massive service provider network and having these tie-ups with specific application providers and building that kind of a learning into the network to say, here's my optimal route. And if that particular optimal route is not available, here's a backup optimal route. Right? That's what we've been looking at from networking perspective to say, how do I migrate some of these users real time? So if you go back and look at 3GPP specifications, obviously there's capabilities like SSC modes, right? Service and session continuity modes, where I can re-anchor the device into a different location within the network. Right? But for that to happen, I need to know the device capabilities, because not every device is going to be able to support that. So it's going to be a combination of 3 or 4 different things that we have to take into account. What is the type of network? What does my edge compute environment look like? what is the device capabilities, and then on top of all of this, does this user actually require that kind of an experience? Are they a premium customer that is actually paying for it? Because at the end of the day, we need to be able to monetize some of this stuff, right? So you got to tie all of those people.
Yeah.
I also think from an enterprise perspective with P5G, we're kind of anticipating islands that are going to start to evolve, and we're building solutions around that. So making sure that as an enterprise engages in 5G that may need to talk to another enterprise for whatever reason, we've got technology in the middle of that to make sure that whether it's a network slice or whether it's 5G or any of that, there's a layer of essentially IMS on top of that that's going to direct some of that.
Yeah. Tomasso, were you going to talk about any research areas?
Yeah, no, I think again, for us, AI at the edge has a lot to do with network control, closed loop network control, and inference within the network, right? And we sort of mentioned before that Open RAN enables this in a way that we didn't have before. You can observe data made available through the open interface, train models that can optimally react to the current network state to perform control actions. But now different control functionalities require different input data. They have different scale and different time scales. Some can be executed in centralized locations. Some need to be executed very, very close to the radio, right? And ORAN defines all these abstractions and non-real-time RIC for functionalities that have large time scales, like controlling slicing policies, etc. And then the XApps that run on the near real-time RIC to control things like scheduling policy, traffic steering, etc. But there's also functionalities that are today not standardized by ORAN and that would require time scales that are below 10 milliseconds and require being executed very close to the radio interface, where they can get access to the digital samples or other authentic real-time information that is needed to execute the AI and make execute the decision making. And so I think that there's a lot of pretty exciting things that can be done in wireless and AI by gaining this authentic real-time control of the network that go from things that have to do with optimizing the communication process. You can think of applications executed at the end, control applications. I mean, we call them usually DApps, distributed applications, that can control in a very sophisticated way the waveform parameters to adapt in real time to channel and traffic conditions. Very sophisticated beam steering strategies for millimeter wave system, etc. Or you can think also of distributed applications that can perform real edge functionalities, like maybe doing computer vision applications directly on the IQ samples, right? Or something that that can really speed up the processing time like that. So I think that, again, that there's a lot of exciting opportunities in this space.
Yeah. Daniel, do you have anything to add?
Yeah, I was going to add one thing. I think maybe I'm a little bit biased being in a group that focuses on security, but I think that one of the challenges that we see would be just how do the AI ML algorithms that we develop for the network degrade? So, for example, if we have a machine learning algorithm that's performing some type of optimization for traffic steering, but the network is undergoing some attack, how does that degrade? Is there a graceful degradation to that algorithm? Or if it sees out of distribution data, does it kind of fall off the cliff? So I think that's one of the things that we see as a particular challenge, both in just practical implementation, but also for people to trust these technologies and implement them, both from an operator standpoint and implement them in their network, and from a user standpoint to trust the network using them. So I think one of the things that we are working on within our group at Virginia Tech is how do we create a platform or a framework for test and evaluation of AI ML that we can then There's a very rigorous test and evaluation process for all telecom equipment, any radio that goes into the network. How do we do that if it's an AI ML algorithm? I think we have to kind of rethink that process and what's required.
Yeah,
I think this is a great point. Yeah,
go ahead.
I was just going to say that these are great points, Daniel, and I think there's all these possible attacks to the sort of real-time execution of the AI models, but it's also attacks on the data, right? And I'm sure you're going to be looking at poisoning attacks that can, injecting data that can modify the behavior of your AI models so they perform actions that were not ever intended to be.
Yeah. So I suspect, Daniel, you said testing and evaluation, but I'm going to go ahead and parenthetically put hacking in there too, because I hope you have a team of skilled hackers that are trying to hack-proof some of these paradigms. But let's stay on that subject, right? I'm not going to go to the dark side of the nefarious potential challenges that are there in this conversation today, perhaps another time. But where I do want to stay is in the bigger macrocosm of where we all are. So whilst AI and ML and edge computing have existed for decades, but now we're coming into next generation, especially with softwareization and certainly the networking and communications companies coming into this playground, is that we are here defining a space. And so there's a lot of concerns about the first mover advantage, so to speak, of people that are commercializing or doing research, and how do we ensure that we address some of the concerns that are out there around trust? I know security is a huge concern. That's like a whole week-long series of conversations that can, if not longer. But I wanted to talk a little bit more about trust, because there is an incredible amount of reliance that we have around enabling people to, whether that's on the business or on the consumer side, for us to be able to leverage data, because without the data, machine learning and AI doesn't really have anything to work with. And so I wanted to pose that question to all of you. But before I get to that, I did want to let the audience know that we have less than 10 minutes left in the session here. So if you have any questions for our esteemed, brilliant panelists here, please do post them, and I'll do my best to address them as we're coming to the final lap around this AI, ML, edge computing conversation. But let's go back to the idea of trust. It's a big topic, but I would love for you to just kind of pin the tail on the donkey on some aspect of this that you or your organization has been thinking about. Jeff, I'll start with you.
Well, we're not on the research end of this, but I think with AI, everybody starts to think of science fiction and the robots taking over the world. I think there can be consequences in bias in AI algorithms. We've certainly read a lot about it. But I think, as we introduce AI, we do so carefully, and we do so perhaps in a private 5G network or something that may be network sliced, so that we can control, the robots can't get out. And that's probably the controlled introduction of that, right? How do we get enough data that we need? And certainly our esteemed researchers think about that probably every day. We're using it as part of our application, and I'm going to trust that you're going to fix this for me, right? I'm looking at you guys.
Daniel, you're going to save the day?
Not just me, but we have a whole team that's happy to help.
All right, Daniel. You call me, okay?
No, that's great. Thanks, Jeff.
Okay.
Anyone?
Yeah, and one of the things, Rika, if I may add on this, right? Like, there's a lot of regulatory scrutiny that's also coming into AML, as well as like privacy issues that we are seeing in the market, right? I think we need to build that piece into the model as well to understand who the device type is. Is it a real user? Is it Ravi's laptop that is accessing the network? And then I can go in and apply a certain set of policies that are completely different. So I don't have to really go down to a personal level, but a group level, right? I think we need a little bit of a transparency into this whole AI ML thing to basically say, here's what the network is capable of doing, and here's how we are applying the policy. It's not personalized to Ravi, but it's the group that Ravi belongs to that is getting that policy applied. So being that, providing that transparency into the network is very important. The other thing I see is specifically, you mentioned private 5G earlier, Rika, right? So in that private 5G context, we do anticipate a lot of these devices to be headless devices or IoT devices, machine type devices, right? In those regulatory environments, in those environments, you don't probably have a lot of privacy concerns. You're applying a business logic to that ecosystem that is a lot more flexible, in my opinion.
Yeah. Yeah, 100%. We too are, as I mentioned, we have a very large R&D group, but our private 5G team has been exploring a lot of that kind of collaboration. We announced a collaboration, for example, with VMware, and look forward to additional collaborations, because it does take a digital village. I just made that up, but yeah. So, but Tomasso or Daniel, anything else to add on trust?
I'll take the fifth on trust. Leave it to them.
I guess I'll just add that I think that we see this as a growing issue as people have become aware just how much their data is being used, right? I think, the platforms that exist. So it has to be front and center. Otherwise, I think the end users are not going to be on board with whatever it is, the great experiences that we can provide. I think I personally tend to be a little bit more like hesitant to provide access to my own data, whether it's an app on my phone. So I get that, but at the same time, there are great applications that can benefit from. So I think it's understanding the right level of information. I think what we often see is cases in which the application is trying to take advantage of collecting all user data, regardless of whether it needs that data or not, has resulted in kind of backfire, right? People realize, well, you didn't need my location. Why were you collecting my location? So I think we have to be careful about how we kind of parse. And I think Ravi mentioned like the policy that we apply. So knowing what's really needed.
Well, I think the model that applies to everyone, I think every one of us has experienced this, but occasionally I click on the cookie preferences to see what it is that I'm saying yes to, and it's like it keeps scrolling. I'm like, wait a second, if I had said yes, I would have said yes to all of this. And so we do have to strike that balance between convenience and comfort, right, of that scenario. Okay, so I'm going to do a quick lightning round. I want all of you to close your eyes. You don't really have to, but close your eyes, and the audience too, right? Close your eyes and fast forward to 2025. Notice I didn't say 2050. I'm saying 2025. And I would like for you to do a quick lightning round of tell me what a headline from your organization looks like on the front page of the Wall Street Journal. So Jeff, you go first, and then let's do quickly around the room.
What the headline looks like in the Wall Street Journal. For us, ubiquity is one of the most important things. So I think by 2025, from a network perspective, if we can get to a point where there's interoperability between the edges, that an Instagram user can create their own P5G network as easily as they can a post, how they can start to monetize new things around. By 2025, if standards groups like this and GSMA and if we can agree, I think that's going to create new revenue. So maybe the headline is new revenue.
Okay, great. Thank you. Ravi, just quick headline, please.
Yeah, access agnostic, right? It has whatever AI/ML policy we apply should be seamless to the OT users. That it shouldn't matter whether it's Wi-Fi, private 5G, public 5G. I need access agnostic AI/ML.
Access agnostic. I love that. Okay, Tomasso, headline.
For us, it's going to be a zero-touch network that can self-configure itself from RAN, core to edge.
Zero touch. I like. Okay. Good. That's catchy. And then Daniel, please take us home. What's your headline in the year 2025?
I think if we have something that is along the lines of seeing resiliency built into networks, that would be great. Virginia Tech can play some role in that.
Resilience in networks. That's great. Well, this went by entirely too quickly, but I just want to thank you all for your incredible wisdom, for your leadership, and also for your pioneering spirit in helping break new ground around the space, and for all the research and taking risks and leading us to the edge and beyond. And hope we get to see you sometime in person soon. And I just want to thank the META organization too for hosting our panel today. Thank you, everyone.
Thank you.
Thank you for the opportunity, Rika.
Yeah, thank you.